Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important and difficult questions from May June 2022 paper 1. In this lesson, we will talk about questions from mechanics, electricity and waves. And these questions are not typical type of questions. These questions are most difficult questions. And most of the students, they found these questions are quite challenging in the exam. We will discuss these questions in detail so you can have better understanding of these questions and also you can improve your conceptual understanding of these topics. Let's study together, let's improve together. In today's class, we will discuss paper 1 from May June 2022. In this lesson, we will discuss question number 1, question number 9, question number 18, 31 and 35. These 5 questions are not typical type of questions. These questions are found to be most difficult for many students in May June 2022 exam series. We will discuss these questions in detail so you can have better understanding of these questions and also you can improve your conceptual understanding of these topics. In order to get maximum benefit from this video, pause the video, do these questions first of all by yourself and then compare your answers with my answers and also check solution for better understanding. For question number 1, we need to find out which pair of quantities are physical quantities. First of all, let's try to understand what is a physical quantity. A quantity is a physical quantity if it can be measured. We can call that quantity is a physical quantity. A quantity that can be measured is a physical quantity. And most of the physical quantities, they have numerical magnitude and also they have unit. Numerical magnitude and also they have unit. Numerical magnitude and also they have unit. But some physical quantities, they don't have unit. They are dimensionless physical quantities like strain. Strain has no unit because strain is a ratio between two same quantities. So strain is dimensionless physical quantity. Let's try to find out the answer. If you look at option A, charge is a physical quantity, so this one is right. Ampere is not a physical quantity. Ampere is unit. So this is not a physical quantity. So the answer A is incorrect. If we go to B, efficiency, this is dimensionless physical quantity. Dimensionless physical quantity, but kilogram is a unit. So B is also incorrect option. If we go to option C, in this case Pascal, Pascal is a unit, is not a physical quantity. But strain is a physical quantity, dimensionless physical quantity. So C is also not possible option. If we go to option D, period is a physical quantity. Potential difference is a physical quantity. So the answer for this question is D. So we need to understand the difference between physical quantity and unit. Then this question is quite straightforward one. For question number 9, it is given to us a ball is dropped onto horizontal ground and bounces vertically upwards. When the ball is in contact with the ground, the following forces act. The weight of the ball, the contact force P exerted on the ground by the ball, the contact force N exerted on the ball by the ground. When the ball is in contact with the ground, the ball is stationary at that moment. At this instant, which relationship is correct? So first of all, we need to understand forces acting on the ball. The first one, this is the force acting on the ball by the ground. So the weight, this is weight of the ball, means the force of gravity acting on the ball by earth, and this is vertically downwards. This is not the force acting on the ball, but this is the force acting on the ball. N is the force acting on the ball and this force is acting vertically upwards. We need to find out which relationship is true. When we draw the free body diagram, we need to consider forces acting on the object. So we only need to consider forces acting on the ball. So very important point, forces acting on the ball. Forces acting on the ball. So this is the main concept. Forces acting on the ball. And in this case, there are only two forces acting on the ball. It means this option is not true. This is also not true. So our answer can be C. Our answer can be D. Now confusing part is that they have mentioned at that specific instant ball is stationary. So we need to find out, is there any resultant force acting on the ball or there is no resultant force acting on the ball. Let's try to understand this one with one simple example. First of all, imagine that we have one ball and we throw this ball vertically upwards, and when the ball is at maximum height, the speed of the ball will be equal to 0. Now can you please tell me, this ball has acceleration or not? Try this one first by yourself and then I will explain. Is acceleration of this ball is 0 when the ball speed is 0 or not? I hope you have tried, so let me explain to you. Acceleration at this instant, A will be equal to G. The reason is that the resultant force acting on this ball, let's say the mass of this ball is m, so the resultant force acting on this ball at that moment will be equal to mg. So we can simply say F net means ma, this is equal to mg. So mm cancel, A is equal to G. So it means this ball has acceleration even the speed of the ball is 0. So let's try to understand what is acceleration. Acceleration is equal to change in velocity over time taken. Change in velocity means that there can be change in magnitude of the velocity. We can say magnitude of velocity, or there can be change in direction of velocity. So in this case, direction is changing but speed is not. Speed is 0. So it means as direction is changing, there is still change in velocity, there is acceleration. This is very confusing point for many students, or simply we can say misunderstood by many students. So in this case, ball has acceleration because direction of velocity is changing, so there is acceleration. Now if you look at this given situation, in this case you need to understand. Let me explain you this one with one simple demonstration. Imagine that this my hand is my ball. When the ball will go down, it will touch this ground, its shape will change, it will deform, and then it will regain shape and it will come up like this. So in this case, there is a resultant force acting on the ball. So let me redraw here. So imagine that this is the ball, it is coming down. First of all, the ball is like this, then its shape will change, and then again it will regain shape and it will move vertically upwards. As it will go vertically upwards, it means that there is resultant force acting on the ball even when the ball is at rest. So in this case, weight is acting down but N is acting up, and N is greater than W. So that's the reason ball will go upwards. Mean direction of motion of the ball is changing. So in this case, N has to be greater than W. So there is resultant force when the ball is even, its speed is 0, ball is at rest, but direction of motion is changing. So there is resultant force, there is acceleration. So ball go vertically upwards, it means N is greater than W. So the answer is D. So D is the best possible option. Very nice question to test your understanding of resultant force and acceleration. For question number 18, it is given to us a car of weight 15,000 newtons is traveling along a horizontal road. At one instant, the thrust force from the engine is 12,000 newtons and the resistive force acting on the car is 3,000 newtons. The velocity of the car at this instant is 24 meters per second. We need to calculate power output from the engine at that instant. It simply means that we need to calculate P instantaneous. In order to calculate P instantaneous, we need to take thrust force from the engine at that instant and we need to multiply with the speed of the car at that instant. In this case, thrust from the engine is given, that is equal to 12,000 newtons. Then the speed of the car at that instant is 24 meters per second, and if we multiply this one, we will get our final answer. 290 kilowatts. So this one is the final answer. So the answer for this question is C. But confusing part is that most of the students, they calculated in the exam P useful. They calculated P useful. That is equal to 12,000 newtons minus 3,000 newtons time speed of the car, and most of the students, they got answer B. So we need to understand the difference between P instantaneous and P useful, or we can say P effective. So most of the students, they got this answer because they calculated P useful or P effective. But question was asking to calculate P instantaneous at that instant of time. So they got wrong answer. So this one is not right answer. This is the right answer because question is asking you to calculate P instantaneous. So you need to understand the difference between P instantaneous and P useful, or simply you can say P effective. For question number 31, it is given to us a beam of light of wavelength 400 nanometer is incident normally on a diffraction grating that has 300 lines per millimeter. The light passes through the grating and produces a series of maxima, which are observed on a semi-circular screen as shown in figure. We need to find out what is the total number of maxima observed on the screen. So first of all, we can calculate total number of maxima on one side of center maxima, and then we can calculate total number of maxima. So first of all, let's try to find out what is value of n max. N max. So we will calculate first of all n max. N max simply means that at the center we will see a center maxima. For this one, n is equal to 0. N max means we will calculate in this case number of maxima on one side of center maxima, and then we will calculate total number of maxima. So let's try to find out n max first of all. We have here diffraction gratings, and for diffraction grating we need to understand n times lambda. This is equal to d sine of theta. We need to calculate n max. So simply we can rearrange, we can write down d sine of theta divided by lambda. In this case, we are calculating n max, so theta has to be 90 degrees. So simply we can write down n max. This one has to be equal to d sine of 90 degrees divided by lambda. So we can simply write down here now that n max simply is equal to d divided by lambda, because sine 90 is equal to 1. Sine of 90, let me write down here, sine of 90 degrees, this is equal to 1. We have value of lambda, so we can plug in value of lambda. Lambda in this case is equal to 400 nanometers, so this is 400 nanometers. So now we need to plug in value of t. For this question, number of lines per millimeter are given. So this is the value of n. So we can write down n is equal to 300 lines per millimeter. 300 lines per millimeter. So we can calculate value of t. D is equal to 1 over n. So we can write down 1 over 300 lines per millimeter. Simply we can write down 1 mm divided by 300 lines. So we can convert this one into SI units. So we can write down 1 millimeter is equal to 1 times 10 to minus 3 meters divided by 300. So this is value of t. Now we can plug in value of t. D is equal to 1 times 10 to minus 3 divided by 300. Now simply we need to solve this one. If we solve this, our final answer will be equal to 8.3. So this is the value of n max. But n max cannot be 8.3. It has to be integer. So it has to be integer. It cannot be 8.3. So value of n max in this case is equal to 8. So we have to take the lower integer. So we have to take 8. Means we have 8 complete maxima. Maxima cannot be 8.3. So we have to take the integer and lower integer. So in this case is 8. We need to calculate n total. N total will be equal to n max plus 1 plus n max plus n max. So we have 8 plus 1 plus 8. So we will get 17. So the answer for this question will be 17. So it simply means that on this side we will have 8 maxima. So we have 1, here we have 2, 3, 4, 5, 6, 7, 8 like this. And we will have 8 maxima on this side. 6 and we will have 7 and 8 maxima. So we will have total 17 maxima. So the answer for this question is 17. In the exam, most of the students they mark C, but C is wrong because they didn't include center maxima. So C was wrong answer. A also wrong answer, so this is equal to n max, and B is also wrong. So D is the right answer. Question is asking you calculate total number of maxima. So the answer is D. For question number 35, it is given to us a piece of conducting putty of constant resistivity is formed into cylindrical shape. The resistance capital R between its flat ends is measured. The same volume of putty is reformed into cylinders of different lengths capital L, and the resistance capital R between the flat ends is measured for each value of capital L. For this question, we need to find out which graph best shows the variation of capital R with capital L. Let's try to understand first of all, if the length of the cylinder is L and the cross-sectional area of the cylinder is capital A, then we can simply say the resistance will be equal to rho L by A. So this is the value of R. Now imagine that we make this cylinder longer, and this time the length of this one is equal to 2 times L. So the length of this one is 2L. Now we need to understand what is the cross-sectional area of this face. Cross-sectional area in this case has to be equal to A by 2 because volume remains constant. So simply we can understand V1 has to be equal to V2. V1 is equal to A times L. So V2, if L is double, so the area has to be half. Cross-sectional area has to be half. So that's the reason this area is half. Now if we calculate the resistance of this, let's say this resistance is R1. So R1 will be equal to rho times L, 2 times L divided by A by 2. So in this case, simply we can write down rho times L divided by A, and this will be multiplied with 4. So R1 simply is equal to 4 times of R. Now we can stretch this one more, and this time imagine that the length of this cylinder is 3 times of L. So this one is equal to 3L. So cross-sectional area will be A by 3. So we can calculate value of R2 now. R2 in this case will be equal to rho times L. L is 3 times of initial value of L, and this is divided by A by 3. So we can rewrite this is rho times L divided by A times 9, means 3 multiplied with 3. So in this case we will get 9 times R. We can also repeat this one for L is equal to 4L. So imagine that this one is 4L. So this length is equal to 4L. So we can say this is 4L. So cross-sectional area in this case will be equal to A by 4. So we can calculate R3 in this case. So this will be equal to rho 4 times L divided by A by 4. So in this case we will get rho L by A multiplied by 16. So this is 16 times of R. So in this case we can draw the table, then we can find the graph. So this can be over table. So let's say we have length here. So when this is L, so we have resistance is equal to R. And when L is equal to 2L, resistance is equal to 4 times R. So this is equal to 4 times R. And when L is equal to 3L, resistance is equal to 9 times R. And when L is equal to 4L, resistance is equal to 16 times R. So in this case, you can see as L is increasing with same amount, R is increasing rapidly. So R increases rapidly in this case, increases rapidly. So the best possible answer for this question is D. So this is increasing exponentially. So the answer is D for this question. So this is how you can approach this problem. A is not possible. It means resistance constant, and this is also telling us they increase with a constant amount, constant ratio. The ratio between R and L remains constant, so this is also not possible because in this case ratio remains constant. This is telling us the ratio between R and L is decreasing, so this is also not possible. Actually, the ratio between R and L, this ratio is increasing. So this is the only possible answer.